Hello everybody, it's Multivariable. Today we're going to be finding what is the maximum and minimum value of x squared plus 2xy plus 3y squared, but it's subject to a constraint, which means the x and y that satisfies it to get the max or min has to also satisfy 4x squared plus 2xy plus 9y squared is equal to 100. So this is multivariable calculus, Calc 3, if you want to know, before you want to watch this exactly. So let's use this first, and let's find the partial derivatives with basically respect to each variable. So respect to x, it's going to be 2x, and then we have to treat y as a constant. Sorry, x is y is a constant, this one. It's going to be equal plus 2y, and then there's nothing extra, so that's just plus 0. And then if it's respect to y, then this doesn't matter. This will become 2x, and then this is going to become 6y, and you're going to, what you want to do in this format is you're going to do it lambda is basically just a constant, and really it's just some notation. You can do it without looking, basically, if you don't want to get involved, because it could sometimes confuse you. And basically this is a vector, and so the second vector is going to be the partial derivatives of this. So that's going to be 8x plus 2y, and then the respect to y, it's going to be 2x plus 18y. So I would ignore the lambda, and it's just basically saying is they're not equal to each other, but it's basically this is a multiple, kind of like all you have to really do is cross multiply and set them equal. So do 2x plus 2y times 2x plus 18y is equal to 2x plus 6y times 8x plus 2y. So let's solve that. Let's just expand that. You're going to get 4x squared plus 40xy plus 36y squared equals 16x squared plus 52xy plus 12y squared. So what we're going to do with that is we're going to make that into, well, let's, you can just put like terms together and cancel. So you're going to get 12x squared on this side, 40 is directly at 12xy equals 24y squared. This basically, you can divide both sides by 12, you get 2y squared is equal to x squared plus xy. So this is an important step. So now what we have to do basically is we need to try to factor this in some way. So we're going to complete the square. So we can make this kind of times x plus 0.5y squared. So that means we, sorry about that. We add 0.25 y squared to both sides. 0.25y squared. So on the right side, you're going to get 2.25y squared, which you may know is 1.5y squared equal to x plus 0.5y squared. Now you can square root both sides. You're going to get two equations with difference. You're going to get x plus 0.5y is equal to 1.5y, and then x plus 0.5y is equal to negative 1.5y, and then that is just basically x equals y, and x equals to negative 2y. So these are our two basically situations. So what we do is we're going to take, remember we said that it had to satisfy 4x squared plus 2xy plus 9y squared equal to 100. So let's plug in x equals y, and you're going to get 4y squared plus 2y squared plus 9y squared, which is just 15y squared equals 100. And then you're going to get y is equal to square root of 100 over 15, which you could simplify, but we don't really need to do that. if x equals negative 2y, then you're going to get 16y squared plus, minus 4y squared plus 9y squared, and that's just equal to 21y squared. So it's going to be 21y squared is equal to 100. Y is equal to square root of 100 over 21. So we almost are there, basically. Basically now what we have to do is try to plug in these both into x squared plus 2xy plus 3y squared. But remember, we can still use our x equals y cases. So if x equals y, remember we got squared squared of 100 over 15 inside. But if x equals y, we can also simplify this to 6y squared. So then it just becomes 6 times the square root of 100 over 15 squared, which is just 6 times 100 over 15, which you can just make 23, 2. So it's going to just equal 40. Now, so that's one of our cases. So I'm going to erase this stuff. So we got 40 down. And then also you could do, when x equals negative 2y, remember, then you got a square root of 100 over 21. So if you x equals negative 2y, then you're just going to get 3y squared if you plug in negative 2y for each x in there. And then you can say that, so that's 3 times square root of 100 over 21 squared, which is equal to 100 over 3 times 100 over 21, which is just 100 over 7. So we got this. And then we know that 40 is greater than 107, so 40 is the maximum value, and 107 is the minimum value. And that's how you solve. This is an example of minimizing a quadratic subject to a constraint. Thank you for watching.